Today's class is going to be unrehearsed, which means we've done the inheritance thingy. So what I'm going to do, I'm going to just build something today right in front of you as like developing something involving inheritance, dynamic memory allocation, and everything. If you finish it, you finish it. If not, we continue it the next day when you're doing your quiz. By the way, the 2 quizzes, I'm going to put it up, and you're going to have some time to do it. You have to install something on your computer to do it. So when you're doing it, it's going to ask you to install Respondus on your computer. So you have to do that because it locks your computer and only gives you that. I know you can look at stuff. It doesn't matter. These are all concept stuff, the programming you're going to do. So the next day you're coming in, you're going to have programming quiz in the thing. But I'm going to give you, I'm going to put like 3 quizzes up for concept. And I'm going to give you like 2-3 weeks to do it. So you have, at any moment you feel you're ready for it, start doing the quiz or the concept ones. And you're going to do that outside of the class. But the programming one will be in the quiz, in the whatchamacallit?
Class.
In the
Lab.
In the lab, yeah. So I was thinking to design something, and I said, let's design a class that eventually is going to be a class that represents an essay. Okay? So we start from the beginning, and we're going to create few things and come up, and then try to make something nice out of it. So yeah, because the inheritance is over, this is a freelance class, so that's why I'm doing this. I'm doing something completely unrehearsed. So the very first thing that we need to, we want to create a document. Let's put it that way. Okay, some kind of a document. So if I want to create a document, my document needs to be printable, right? Otherwise, what is it worth, right? So the very first thing I need to do is to create a class that is mother of all. It's a printable object, an object that can be printable. It can get printed. So the very first thing I'm going to do, I'm going to create a class. And as you see, I'm going to do it from scratch as if I'm just designing something. So I'm going to create something printable. Okay? And it's going to have a printable.h, which essentially means it's going to be, if not defined, Seneca printable h. Define namespace Seneca, and class printable is going to go there. We're good? Remember I told you when you want to think about something, first you do this, then you start thinking? That's what I meant. Now I have an empty class ready to develop, and I'm going to have a printable thingy over here. That's going to be namespace Seneca. So it's going to get created in namespace Seneca. So what does a printable class need to do? It needs to be able to get printed, right? So I'm going to say OStream. Of course, I need to include OStream. So I'm going to say include IOStream. Oh. And because it's a header file, I cannot say using namespace std because you are not allowed to use a namespace in a header file. Okay? So I want it to be printable, so it's going to print OStream reference. Oh, sorry, std OStream. Print. And it's going to be a const. And OStream reference OSTR, because I don't know where I want to print it. It should be an OStream, but that OStream may be a file. We don't know. Okay, did we talk about files in this class? We didn't talk about files, did we? No. Okay. So we'll go to it and you'll see it. Probably I'm going to talk about it today in a very quick. Teaching files takes around 10 minutes entirely because you already know, you'll see. Now that you know inheritance, you'll see why it only takes 10 minutes. Anyways, so this is my class, and I don't know how to print yet. So essentially, this becomes an interface, right? That's my printable class, a class that can print itself. Now, I want to be able to print it on OStream using the instruction operator. That's easier, right? So I'll overload that one, and I'm going to say over here std OStream operator. At left side, I have std OStream, reference OSTR. And at right side, I have the class printable. So class printable, reference P. And I'll make this one a const because I'm not supposed to change it. I'm just printing. Although my class doesn't have an implementation because it's an interface, nothing holding me on overloading the operator. So I'm going to go over here and overload the operator saying return p.print OSTR. As simple as that. So essentially, if anybody wants to print whatever I have over here, you can just print it. Are we okay with this? Problem?
Equal 0, what does it mean?
It means it's a virtual function. And it's a pure virtual function. It doesn't have a body. When I create a pure virtual function, back to what we talked about last time, when you create a pure virtual function, you say anything that is printable should be able to print itself. I don't know how yet, but it's supposed to. So anybody inheriting from printable is forced to implement the print. Otherwise, their class becomes meaningless. Got it?
So equal 0 in this?
Means no body. No body. No, not nobody. No, pause, body. No implementation. Okay? Remember we talked about human beings and talking? And I say a human being cannot talk because we don't know how it's supposed to talk. I have to actually implement a human into a Persian human being, and then it becomes you. And when I say talk, you're going to talk Farsi. And then I'm going to say it becomes a, what is your background? Yeah, what is ethnic? Where are you from? Taiwan. So, and I inherit that human to a Taiwanese person, then he speaks Chinese. There we go. So I don't know the language. I'm just mentioning. Okay. So that's Chinese. Do we have a language like that? We don't. Do we have a Chinese? I thought it's like Mandarin and Cantonese. Okay, okay. Because I remember when I had a friend a long time ago. I said, "You speak Chinese?" There is no language called Chinese. I'm like, okay. So what it is I speak Cantonese. I said, oh, okay. Now I know. Okay. So I'm trying to learn, man. So that's why. So a human being can talk, but it's equal to 0 because you don't know how. First, you have to. Just to give you an example of this, for example, if I want to have a title is supposed to be printed, right? You should be able to print a title. So I can actually create a class, and I call that class title, and that class has a base class printable, okay? And when you create this now, it's not wise enough to know that it has to actually put it in namespace Seneca. Oops. So now I have a title, and this title of mine, now again for title, I'm going to put over here for now pragma once. Pragma once is a shortcut for If not defined, yada, yada. But it's not compatible everywhere. So for now, just to be quick, I leave it like that. But later on, make sure you change all these things to proper safeguards. As a matter of fact, let me do it because I know somebody's going to say, oh, I saw that over there. And this. OK. If not defined, Seneca title H. OK, so now I have the title. I'll go to title.cpp. And I'm going to say namespace Seneca. OK. What should a title have?
A string.
A string. And I want that string to be dynamic. So what do I define over there? To hold a dynamic C string, what do I write? If you don't know.
Character pointer.
Character pointer, you're my hero. OK, character pointer title. So that's going to be the title that I'm going to have in here, right? Now I'm going to create a public constructor. And in this constructor, I'm going to instantiate this title to get created with a title. So I'm going to say over here title, const character pointer title, OK? And I'm going to set it by default to blank, OK? And immediately I'm going to create a destructor, OK? So far the prototypes look good. Any problem with my prototype? Sure, thank you. OK. Oh, no, good. Very good. Rule of 3. But OK, I'll ask the question later. So could you please pass the microphone to my Taiwanese friend? Yeah. No, because you didn't say anything yet. It's your turn. OK, you're going to go. OK. So rule of 3.
Rule of 3. How to explain? Because
No. Yeah. Not why. Tell me what should I write.
OK.
What should I implement now for rule of 3?
Copy constructor.
OK, so it's a constructor, so it's got to be title. Well, what do I pass over here to it?
Another type. Yeah,
What is the type?
The type. Title.
Title. What type of title?
What type of title?
It has to be a constant one. Constant one. And it has to be a reference.
Yeah,
if it's not a reference, then it's going to be a. If you don't put a reference over there, then it's going to be a recursive thing, which means to call the copy constructor, because it's passing by value, it has to call the copy constructor. So copy constructor to be called will call the copy constructor. That will call the copy constructor. That will call it. So you have to make sure that this is a reference. If you don't put a reference over here, you'll be in trouble. OK?
Yeah.
So the next thing for rule of 3 is?
Copy assignment.
Copy assignment. So copy assignment is operator equal. What does it return?
Type.
What type of title?
Reference.
Fantastic. And the other one, I'm not going to bother you. Title, you can pass it now to the gentleman who had the microphone. OK. So now in here, it's going to be T. So that's going to be. So that's rule of 3 that you mentioned. OK. Now, what is wrong with this code? No. We want to. If you call it to delete, it means I don't want it to be copied. I want my title to be copied. I don't want to say equal to delete. Equal to delete, it means forbid. I don't want to copy it. What's wrong with this code? Am I recording? I hope I'm recording. Am I recording? Yes. And does it record the audio? Yes, it does. OK, go. OK, one more time. Go ahead. What's wrong with it? Hurry up. Oh, yeah, we have to implement that. I'm sure. So, OK, so still, that's not the problem. OK, it is because it's printable, it must implement the print. So I have to, and you literally have to go over it to make sure you are overwriting it. You have to exactly copy that and come back over here and add it to your title. Exactly that. And this one is not going to be equal to 0 anymore because I have to implement it. Otherwise, my title means nothing. Again, what's wrong with this code?
Choice of print.
Yes, it is. That's a beautiful thing. What's wrong with this? What's wrong with my printable? There are two problems over here. Huge problems. That is going to cause lots of memory leak. What is wrong with these two pieces of code in here?
Is it that you're not deallocating it? No.
No. Forward declaration is only needed if you need the declaration before that. I don't have anything. Title knows what's printable. Anyone? You lost a good 2% for final. There are two problems with this, actually. Number one, when you create a class, you always add a destructor to it, especially when it's an interface. So this must have a destructor. And it must be defaulted because this is just an interface. It just have and still there's a problem with this. Last chance. Okay. I said from today till the day you die, you must make sure when you're writing C++ code and you create a class, your class must have a destructor and the destructor must be virtual. So that's the problem that I had. Because that destructor wasn't virtual, I would have memory leak. Okay? No 2% to anyone because you did not remember it. Okay? So that's that. Now I'm ready to actually implement. Okay? So everything's fine and dandy. Yeah. Let me actually see, do I have utils anywhere over here? Did I put the utils in the workshops? Do you have utils in workshop with, huh? No, milestone utils is nothing. I have a big utils with all the stuff in it. Did I have it anywhere in here? Anybody remembers it? There you go. Let me see, where is it? Let me see, how is this one? Object? No. Oh, animal. I think animals utils will do. Let me see. I'm going to copy it. Hopefully it has everything I need. Add. Existing item. Let me see. Where is utils?
The last word.
Yeah, it has all the good stuff. Does it have allo copy? It doesn't have allo copy.
The professor's one does, I think.
No, it doesn't. I wanted to bring it from somewhere, so let me check the .h. How come it doesn't have all these good stuff and not a single allo copy? We'll write it. Okay, so to allocate and copy a string, what do we need to do? Let's bring it over here. So to allocate and copy a string, I can do it in two different ways. One, I'm going to say character pointer. I'm going to say allo copy. Okay? Allo copy. And allocation and copy at left side, I need a character pointer reference because I need to be able to allocate it and pass it back. So that's the destination. And the right one's going to be the source. So I'm going to put over here constant character pointer source. So that's going to be my function. And utils.cpp, and I have string copy, string, I have everything. Good. So now what I can do over here in the allo copy, in here, first thing I need to do is to make sure that destination doesn't have anything in it. So first of all, delete destination. Okay, destination has to get deleted. Then I have to, what do I need to do? I have to set the destination to null. Now, if source actually exists, I need to copy it. Otherwise, I shouldn't copy, right? If it's null, I shouldn't do anything. So now I'm going to say, what do I say? I'm going to say destination will be set to new character, strlen of source +1. And now I'm going to say str copy. And these are all from the utils itself, so I don't need to worry about it. Into destination, the source. And then at the end, I return the destination in case they want to use it. So it returns it in two different ways. Does it work? Is it OK? I have to stand for and look at it. So first, I'm deleting the destination. Make sure there is nothing in it. Then I set it to null. In case source is null, that has to be null. Always remember, after you delete, you set to null to make sure it's in a safe empty state. Then if source is not null, it's going to set destination to new character, strlen source, yada, yada, yada. Then it's going to copy. Then we are good. OK, so that's that. OK, so now let's write the title. This is kind of a review on all the stuff that we have done down to this point. So take the opportunity and ask questions if I may get any boo-boo. Another thing that we need to remember, you always initialize the values that you have for your attributes. It's a good practice. You put an empty curly bracket in front of it, it will be universally defaulted, whatever it is. So anything that it's there will be defaulted. And if the thing you have over there doesn't have a default constructor, it's going to give you an error, so you know you have to initialize it. So it's a good thing to do. Got it? Okay. Another thing, I could have done another allo copy too. You know what? I'll create another allo copy too. So I can have two. Forget it. I'm one of these people. Like, remember, when you're programming, don't be like me. My programs never end. Because I keep programming, and I say, I could have made it better. And I'm going to write another function. I keep writing bells and whistles so many that I forget what I wanted to do. OK? So yeah, don't be obsessed with it. Yeah. Anyways, so I'm going to create the constructor first. And for the constructor, this could be your final test. It's a perfect thing for a final test, OK? So for the constructor, this is a copy constructor. I said constructor. OK, so I'm going to create the constructor. For constructor, I'm going to say, what am I going to say? I'm going to say allo copy. Oh, utils. I have to include utils first. Utils. Remember, if you're using this utils, you have to cite it in your whatchamacallit, not workshop, in your project. So if you have used the utils stuff of mine, make sure, and you still have a chance because I haven't ran it through the plagiarism detection. So if you still have a chance. If you did not cite, you can resubmit again. Okay, you can resubmit the code, and the last submission is the one that counts. So if you haven't cited something, make sure you cite it. Okay. So allo copy. Now I'm going to say ut.allo copy. Was it ut? What is utils doing? Yeah, it is UT. So why didn't it recognize it? Is it in Seneca? Oh, it's STDS. Holy mother, that's old. Okay, Seneca. That's not STDS, Seneca. That's when all the programming things were in one school. Now we are two different schools. Anyways, so now now it's going to work. So I'm going to say UT dot, there you go, allo copy into mtitle, the title. What is good about reusing your code like this? The good thing is that if you make a mistake, you are making a mistake at one place. Don't keep repeating a logic here and there and over and over and over. Having something like a utils module with all the useful stuff that you're doing in it is extremely useful. Because if you make a boo-boo, you fix one place and everything that is using it will be fixed. So it's a good idea to do this. Okay, so allocate and copy. So for the copy constructor, it's the same thing because it's a brand new object. I'm going to say UT allo copy into mtitle, whatever T's mtitle is. Right? I could have, like you could have called the assignment operator as people do, but I don't do it. I see what is needed and I do it that way. So I want to copy a title. I have to copy the title of that one to mine. So it's doing it. Life is beautiful. Nothing to complain. We're going to continue with the title in here. So continue the title. And what else do I have? Destructor, extremely important. Although you don't need to write virtual over here because the parent is virtual, but do it anyway. Why? Because it becomes like a documentation, a comment for a next person who's inheriting from your title, not knowing that printable is virtual. That kind of put them in peace. Okay? So adding virtual will help. And this is an easy one. I just delete mtitle. Okay? That's that. And the next thing I want to do is to create the assignment operator. Get ready, the next person. Okay, when I'm implementing the assignment operator, what is the very first thing I need to do?
Check the argument is equal to...
Yes, it's a very simple thing. Self-copying test. That's called self. Make sure it doesn't self-copy, but perfectly correct. Pass it to the gentleman behind you. So the very first thing I have to do is to make sure it's not self-copy. How do I know if two objects are the same? Because we know that we may have several references for the same object. How do I know if they are not? You check their addresses. That's as easy as it can get. Okay? Because the address of the current object by default is in this, I can simply say if this is not equal to address of T, then I'm not doing self-copy. And in here, I'm going to say return this. Always programmed like this, which means complete the structure of the code and then continue coding. First of all, makes your code less erroneous. You're going to have less errors in it. Okay? And secondly, in a test, when I see something like this, you already got almost 70% of the mark because you have the proper signature. You did your self-check. You returned this. All you needed to do was copy, so that's the only thing you're going to lose mark. But if you miss semicolon here and there and it becomes a mishmash, then I don't know what you know. Okay? And it keeps your code organized. So you got to start learning to program like this. Okay? So now what I need to do, now the difference between assignment, what is the difference between assignment? It's a difficult question to ask, but what is the difference between copying in an assignment and copying in a copy construction? What is the major difference between the two?
Is it that one copies the address and the other one copies the...
No, they are both copying the content. They are both making copies of already existing objects with one major difference. Do you know what that is?
Accessibility?
Huh?
accessibility?
No.
No, I don't know. That's
What do you think? Sure. My lady? You don't know? You know? What does it mean? I want to know if you're. So, yeah, in a copy construction, you have to make sure everything is initialized before you do anything. And when you do this, then you're comfortable with that. Because if you have the habit to have that thing in front of your attributes, you don't need to worry about it. Because everything gets initialized in any constructor. You don't have to do it in constructors one by one. Okay? Well, what is it that we need to do in here?
Copy constructor constructs a new object. Copy assignment operator already has the object constructed.
2% for final. Okay. So the only difference between the two things is that when you are writing a constructor, there is no object. You are creating something brand new. You don't need to worry about reassigning memory. In assignment operator, you already have an existing object. You are overriding it with another one. Therefore, you need to worry about with already existing data. Therefore, you have to first wipe everything up, which means you have to say delete mtitle. Okay? So first you have to delete mtitle, make sure everything is gone. Yes?
Could you repeat again the frame?
Okay. When you are doing wow, we already have so many files. Okay, so if I include title over here, and then I write over here, what do I write? Then I write over here using namespace Seneca. So if I create a title, so essentially I'm going to do this. Title T or lecture, and I'm going to say equal to so this is what I've done, right? Title lecture, and I'm printing the lecture, right? This is what I'm doing. Correct? Now, if I write, oh, this assignment is not assignment. This is constructor. So this essentially, this line is the same as this, or these three lines are identical, people, please. Assignment at the moment of creation is a call to one argument constructor. You have to always remember that. Okay? So for this one, there is no lecture. It is creating a new one, right? Now, if I want to create another one over here, so these two I'm going to comment. So if I write something like this over here, title L2, and I'm going to say set to lecture, now I am copying lecture into L2, correct? But L2 is brand new. It doesn't have data in it. Do we understand that? But if I have over here something like title L3, whatever. Now, if I say L3 is set to lecture, now L3 has data. This is assignment operated. This is not a copy constructor, which means you have to first remove whatever it has before you do anything. Does that answer the question, hopefully? It does. Hopefully. So that's now. So therefore, I have to delete. And then I have to make sure mtitle is null PTR. Then after doing all this, what do I need to do? I need to see if the other titles, M title is not equal to null. Wait a minute, doesn't that look familiar to you? Delete M title, delete destination. M title, no, if. You see that? It's reusing code again, right? So all these things I can do, simply say allo copy into M title, t.m title. So that identifies exactly what the difference between the two is. Okay? Now, allo copy is doing an extra step that you don't need in the constructor, which means it deletes the thing. But because that's null, nothing happens. That's why I wanted to write two different types of allo copies. So that's why I want to have two different types of allo copies, one like this and another one like this. Which is essentially nothing but this. So it's gonna have, I'm gonna bring this over here. The difference between this and that is that in here I'm gonna have character pointer destination that is null. And I do it like that. So the difference over here is that it's not deleting anything. It just grabs a piece of character pointer and copies it and returns a copy out of it. So it would have been better that I use that one to exactly write what I mean. So essentially, I could have written over here M title is equal to allo copy t.m title. Which means in copy constructor, you don't need to delete anything. You just set it to a newly allocated memory, where in assignment operator, you have to first wipe it out. And then, does that make sense? OK? So this one, just allocate. This one first delete, then allocate. We good? Yes. No, using this one? Yes. Nothing. Absolutely nothing. This just makes it more readable. This is because I'm teaching you. I want you to see this, to see, oh, this is something completely new. And this is something that already exists. So this is the way of teaching you what's happening. But if I would write the code myself, I would have never created the other one. I would just use this one. Right? Okay. All right. So we are good. Now we have the title. And the only thing I think we need to do is to do the print, right? Yeah. So the only thing we need to do is to do the print. So I'm going to say create definition. And in printing, what do? I'm going to say if title OSTR title and return title. OK? No, return OS stream. What am I doing? OS stream. In real life, you don't print stuff, error messages and things like that. Usually things like this are silently ignored. So if I don't print anything, it means the title is empty. I don't need to check to see if it's null or whatever, right? You follow, right? Okay, so that's that. So now if you see my title over here is not overloaded with cout, right? My title is not overloaded with cout, but in program.cpp it appears to be okay. So now I can come over here and I can say lecture and then L2 and L3. Okay, I'm going to run it first, see if it crashes. If it doesn't crash, then I'm going to walk through it. There we go. So it's printing the thing 3 times. So essentially, now I created a title. Now, you could later on add bells and whistles, put the title in a square, in a frame or something. I'm just writing it as simple as it can get. Are we okay with this down to this point? Right? So that's my title. So now I know how all these things working. The next thing I need to do is to think one step ahead. And now that I have a printable and I have a title, what do I need is having a document. So I need to have a document. What a document is, let's see. So I want to see how can I go from printable to essay through 2 steps of inheritance. So I have a printable object. The printable object can be a document. Yeah, why not? Can be a document. Okay, so now what I need to do over here is to create the next step of inheritance, which is essentially creating a document. Now I'm going to create a class document that comes out of the printable. Okay? So let's close this utils thingy because I'm going to bring the header file and use whatever is needed. So now I can actually create a document. So I'm going to create add a class that is called document. Let's call it document is too long. Okay? And it is a printable object, obviously. Printable object. And a document has a title, right? Okay. A document is a printable object that has a title. So the title over here is not something to inherit from. Okay? Be aware of it. So let me first do this. I'll do that pragma thingy later. So namespace Seneca. And I have that one. And I'm going to go to doc.cpp. Namespace Seneca. So if I want to create a document, what do I do? First of all, I need to have a title. Therefore, I need to include title. Right? We good? And then in here, I'm going to say, all right, so I have a title, mtitle. That's the title of my printable document. And I'm going to have other stuff in here. Okay? Definitely, there's no question that I need to have. Do I need rule of 3? When I need to see if I need rule of 3 over here. Do I need rule of 3? Title has everything. It knows how to copy itself and everything, right? If the document that I have over here, have something that is dynamically allocated, then I need to create rule of 3 for it. Okay? If it doesn't, I don't need to, because if I copy a document to another one, it copies all the pieces. One of those pieces is title. And because title knows how to copy itself, its copy constructor will be called. That's one step of classes with resources, inherited classes with resources. Although this is not inherited, but remember, if the attributes of your class, they know how to copy themselves, they have the rule of 3, and your class doesn't have any resources other than that, don't worry about it. The copying will be done automatically and properly. Are we good down to this? Okay. The class ends at 12:30. 12:30, the other begins, or this one ends? You remember? This one ends. Okay, I have to set a timer because I know I'm going to keep going. And you guys can have a break, okay? So actually it ends at 12:25. The other one starts at 12:30. So I have to 12:15, okay. Set an alarm at 12:15.
All right, your alarm's set for 12:15 p.m.
Okay, now go for a break because I see everybody's falling asleep. I know it's dry and in coding and stuff like that, but I just want to write the code for you to see what it is. I'm going to add some stuff over here while you're gone. Oh, and stop the recording. Pause it. Just to show how derived classes with resources work, I added a few things to it. I added an author to a document, so I have an author. And my document receives an author and a title. And it can copy itself. It can be assigned to another document. And it can get printed. I can have a word count to see how many words my document has. I don't know how to count it yet. That's why it's pure virtual. So it means anybody who's copying from this document, and it's going to take care of that. It has a destructor. So the constructor is straightforward. So I have to show you how I created these things. And this time I used the initialization area to do the thing. So essentially, this is my document's constructor. So I'm receiving an author, constant character pointer, and a title, constant character pointer. Okay? And they both must be provided. Otherwise, I don't have a document. Then I'm going to say, initialize mAuthor with a copy, dynamic copy of the author that is being passed over. So this allo copy of mine will actually create a dynamic copy, return the address, and my author will be initialized by that. Are we okay with this? Number two, for this one, I don't need to call anything because it already has a constructor. So I'm going to say create the mTitle using a one-argument constructor that accepts a constant character pointer. Therefore, mTitle is created. So when my document gets created, the author and the title are set to it. For copy construction, I do the same. I'm going to say I just copied that one over here and put a D beside these things. That's all. So I said, when the copy construction, now when you are implementing a copy constructor, then ball it as at your court. You have to do everything. Nothing happens automatically. Remember that. If I did not have a copy constructor, I didn't need to worry about mTitle being copied because it has a copy constructor of its own, and because when it gets copied, it copies all the pieces, and therefore yada, yada, yada. But when you are writing the copy constructor, now you are telling to the compiler, don't copy, I'll take care of it. Then you have to do every single piece yourself. Therefore, I'm going to say the mAuthor of the copy that I'm creating is a dynamic copy of the other object, author. And mTitle is a one-argument constructor that accepts another mTitle, which is a copy constructor. So essentially, call the copy constructor of mTitle to create a copy of the title of the other document. Are we good? Are we good? Why? Okay, first. mTitle is a title, correct? It has a copy constructor. We designed it. Okay. All right. For assignment operator, what do? First, I'll check to make sure it's not a self-copy. Then I'm going to say, assign the title of mine to that mTitle, whatever it is. I know I've overloaded the assignment operator, and that takes care of everything. Rule of 3 is designed for title. I don't need to worry about it. But for the author, I have to allo copy with deletion, which means the current author must be deleted, replaced by the author of the other one. And then I return this. For destruction, I don't need to do anything with the title, because when it gets destroyed, all the parts of document will get destroyed. One of them is title. Therefore, the structure of title is called, because rule of 3 is implemented, no problem over there. But the dynamic author must get deleted. OK? Many of you, as I told you, by habit do this. OK, it's time for you to know when you need to set it to null and when you don't. When the object is getting destroyed, who cares if what is going to garbage is null or not? So only make it null when there is a slight possibility of it being reused, like I did it for the auto cup. Okay. Now, how do we print a title? We print a document. We print a document by printing its title first, right? So I'm going to say OSTRM title. That's the first thing I'm going to do. And then you have to go to new line, right? So first it goes to new line. Now that it's gone to new line, I need to see if author exists. I do have an author. Maybe it's null, right? So I'm going to say if author exists, then I'm going to, in new line, I'm going to say OSTR by, and I'm going to put the author name. So the title by the author, author. Author. Do I need to go to new line after the title? I think so. Because usually when you're overloading, when you're printing, you let the other thing, if a new line is needed, they add it. But have you ever seen a document where the author and stuff is at the top and it's not at its line of its own? No. So I think it should be going to new line. Again, this all can change when you are doing it later. And return OStream is OSTR is there. So now this shows classes with resources who has classes with resources as an argument. OK? I didn't still go to the hierarchy. So next day when we are coming in, I'm going to actually do something like an essay out of document. Think about something, please. OK, come up with ideas. So far, that do like this. Out of this document, create a class like this. OK? So I think I wanted to do an essay, so with paragraphs and lines being added to it, something like that. I'm just thinking out loud. OK? So yeah. So that's that. So that's my document. And now I can actually test it and see if it works or not. I can actually get to, and in next 15 minutes, I'm going to teach you the files. So you know actually how files work. OK? So number one, let's try this, see if it works. So I'm going to come over here. And so this is I'm going to call it title tester. What these testers are called? What is the technical term for these testers? They're called unit test. OK? These type of programs that you write to test pieces of application, they're called unit tests. You always keep all the unit tests in some kind of a directory somewhere. Because in future, when a bug happens, you want to bring the unit test and check each unit of your application separately. That becomes very handy. So make sure you have your unit tests with you. So now what I'm going to do over here, I'm going to create a document. So I don't need to include title because I just want to do document. Again, you only include what you need to use. Never include just in case. That's a very bad thing to do. OK? So in here, I'm going to say doc lecture. And the author is Fardad Soleimanlu. And the title is today's lecture, right? Why is it giving me that? Object. Oh. let's say we don't have the word count now. Because I see that's a beautiful thing now. Now we know that we have a pure virtual function. You cannot instantiate it. So we'll do it later. For this unit test, I'm going to comment this. OK? So one of the ways that, so I'm going to do like this, 1, 2, 3. And that gives you the summary. Returns the number of words in the document. Docu integer value. OK? So, and now I'll comment it. By the way, when you do something like this, when you do 3 slashes, anywhere you hover over it, it gives you the comment. It's very helpful. So when you are writing your code, add 3 slashes. That's standard. It comes. And remember, what you write in here is HTML. So you cannot use less than and greater than. If you want to do less than, what do? Ampersand LT semicolon, right? So remember, this is an XML document, therefore HTML. If you want special things to get printed, you have to actually write the HTML code in there. So I'm going to comment it. OK. And run it. And now it's better. OK, so now I have the lecture created over here. I'm going to say over here, cout lecture, just to show you what I did over there. That's the thing that, so if I run this program, it's going to say 10 Mar20 OOP244NAA, and by far that's only Malu and draws a thing underneath. We good? OK, now, you know how to work with cout, right? We talked about inheritance, correct? And we said when we have inheritance, what do we have? We have this. So my markers are missing. I think I left it in the class last day. I have only one red one. OK, so in hierarchy of inheritance in hierarchy of inheritance in C++, at the top, there is a class called iOS that has all input, output, system stuff in it. That's iOS. OK? Out of this iOS comes out IOStream. OK? Out of IOStream come, actually, let's not do that. Sure. Out of this comes iStream. And this one comes OStream. iStream and OStream, they have, Mr. Muhammad, iStream and OStream, they have private constructors. You cannot instantiate them. They did magic, and they instantiated them. OStream is instantiated into cout. So the name of this cout object is actually an OStream object. clog and cerr. There are 3 objects you can print on. They all are OStream. So if you know how to work with cout, you know how to work with clog, you know how to work with cerr. They're all the same. They're sisters. Why? Because if your cout fails, you want to be able to print an error. So this is going to be the one you're going to be writing with. OK? You got it? iStream is instantiated into cin. So all this stuff that you're doing to cin, it's actually the iStream object. Are we okay with this? Now, iStream is inherited into another object called ifstream. Now, ifstream does not have a private constructor. It actually has a constructor. You have to construct it. And also, this one is inherited into OOP244NAA. I don't know how to write. Okay? Then these two got married, and the result was fstream. So, when you have an instance of ifstream, how does it work? Exactly like cin. I don't need to teach anything about it to you. You know how to read from keyboard using cin. You know how to use this one. When I tell you OOP244NAA, it's an O stream. Therefore, anything you did on a screen, you can do it on this one. No difference. Do we understand this? Okay, now. In here, I'm going to say, so this one is doc tester. So now see what I'm going to do. In here, I'm going to first say include fstream. All these, oh, I'm cleaning it up with my shirt. Okay, so ifstream, OOP244NAA, they are all in fstream header file. Remember that. These three are in fstream header file. These two are in iostream header file. Okay? So in here, what I'm going to do, I'm going to say OOP244NAA, okay? Let's call it, what do I call that? File. Now, if you wanted to create a constructor for a file, what would you pass to its constructor? A file name. Duh, of course. So in here, what I'm going to do, I'm just going to put a file name in there. What do I write? Let's call it lecture.txt. Okay? Now, if you would write, did you have any files in IPC 144? So before you write into a file, what did you have to do? Open it, right? After you are done, what did you have to do? Close it, correct? I have a constructor. Definitely any wise programmer, when you write in a constructor, he will open the file in the constructor. So there is no need to open, although you can. You can just create file, and they say file.open and put a file name. But if you are passing a file name to the constructor, the person who wrote it is sane enough to open it. And because it has a destructor, you don't need to close the file anymore. When the object is dead, it will close the file. If you want, you can manually close it to dump everything, but it's your choice. Okay? So now, look at this. Look what I'm going to do. You see the C out over here? I'm going to say file. Done. Do I need to overload it? No. Why? Because the printable over here is overloaded for OStream. OStream is mother of OOP244NAA. Therefore, it can be used as such. There's no difference. Don't we say it's an is-a relationship? So OOP244NAA is an OStream. Therefore, it can be passed as that. Doesn't make any difference. And because the action of writing is virtual, when you write on an O stream, the latest version will be called, which is writing in a file. So it's completely transparent over here. I didn't do anything. Just change C out to a file. And when you run the program, obviously nothing's on a screen. And if I open the file over here, you see there is a lecture.txt, and inside is that one. Ta-da! You want to read from a file? be my guest. There's no problem with it. So we have a lecture.txt, right? So in here, I'm going to say C file write.cpp, right? Now, I'm going to come over here. I'm going to say ifstream lecture, right? Now, just for you to remember what we had in a file. Where is the file? Where is the file? Where is the file? Where is the file? Here's the file. So, the very first thing over there you see is what? 14, right? So in here I'm going to say int day. See, I'm going to say file day. The good thing about file is that you don't have the stupid user sitting over there making mistake and you have to keep correcting. You know what the file is. You know what the format is, right? So I look at it and say file day. What is it going to get? It's going to get 14, right? So I'm going to get 14. And it's going to stop at dash because dash is not an integer. So if I run this right now, I can say cout day. And what you're going to see over there will be 14. It read it from the file. OK? Now I want to get the date. I have to skip one character, right? You simply say, hey, file. Ignore one character. Done. So the thing is passed. Now I want to get the date up to the dash, correct? So what do? File dot get line. I need to put it in some kind of string, right? So in here, I'm going to put over here character month. Oh, date. So that's not day. That's actually number. Sorry. That's lecture number. Number. And then I'm going to have date. I don't know. I'm going to put over here 15. And I'm going to say get line into date up to 5 characters, because there's 5, right? So I'm going to put 6 over here. And then I'm going to say and stop at a dash. Correct? So I'm saying get a line, go up to 6, and stop at a dash. If the dash is closer, it's going to stop at dash. If 6 comes closer, it stops at 6. Right? Now I have the date read. So I'm going to say over here num, and the other one's going to be date. Ta-da. You can keep going like that. OK? So now I read up to that point, and getLine actually extracts the dash and throws it away. If you put over here get, it would have not extracted dash. The dash would remain in buffer. So you have to read the description of the thing. So now getLine is reading up and gets the dash. Now if I want to get the subject in here, I have to say character subject 21. It means the class is over in 10 minutes. Now in here I can say file.getLine into subject subject up to 21 characters. And I don't need to put backslash in because it's the end of the line. End of the line is backslash in. So now in here I can say cout subject. There we go. So again, it makes your life even easier. I'll give you the file. You see the format of the file. You write exactly what you want to read right from the file. Ta-da. Life is beautiful. That's it. OK? So file is done. Anything you know about C in and C out, apply it to any file input and output. Fstream is for OOP244. Fstream is when you want to read and write from the same file. We don't do that this semester. In this semester, we just read from a file, write into a file. Ifstream or Fstream. C in, C out. We good? All right. Have a good day. Questions? Sorry. Questions? Suggestions? Objections? Reflection? That's good. Reflection? Objection? Okay. Have a good day. And you know what I'm going to do? I'm going to upload it right now. That's why I ended it quick.